Hello everyone. In this session, I want to look at how we can use R to compute the credit spread, provided we are given an empirical migration matrix. So if I have a migration matrix, so the migration matrix is nothing but we have a set of credit ratings like this, and again we have the same set of credit ratings out here along with default as well being the worst case. Now what is the probability of jumping from the current rating being triple A? What is the probability that the firm will stay in triple A only at the end of 1 year? What is the probability that it will move to double A? What is the probability that it will move to A? And what is the probability that it will move to default? Similarly, currently, if the credit rating of the firm is double A, what is the chance that it will move to triple A? What is the chance that it will stay at double A itself? What is the chance that it will fall to A, double B, triple B, and finally, what is the chance that it will go to default? So we have a matrix like this, and this matrix, as you know, it should come from the empirical data. So what is this empirical data? We are talking about the historical data of over a past few periods, where people have observed a list of AAA rated companies which were whatever the rating was AAA at the beginning of the year, but by the time they reach the end of the year, some of them might be there in AAA itself, some of them might have moved to AA, some of them might have fallen to A, and some of them might have defaulted as well within a span of 1 year. So based on them, the transition matrix is typically developed. So what we are saying is, based on the rating transition matrix, I want to find out how much should be the credit spread that needs to be set. And what is meant by credit spread? Provide if the risk-free rate of return is some R. Now credit spread is saying, as the risk of default of a particular firm is increasing, the expected return that you are expecting out of that particular firm is also higher. As the risk of the firm is increasing, if you have to lend to that particular firm, you would prefer charging a higher rate of return, and that higher rate of return is coming because of the credit spread. And so what we are saying is, based on the ratings, how we can typically decide how much should be the credit spread corresponding to each of the ratings. So the input that we would be looking at is a 1 year transition matrix. So if I have to look at the transition matrix, let me bring that into R. It's there as a part of my ratings.csv file. I'm bringing that into R. So if I simply look at it, it is nothing but it's something like this. You see here, these are the current states. So the current state is AAA. Now, what is the probability that at the end of the year, it will still remain in AAA? So there is a 90.81 chance that a firm which is having a AAA rating at the beginning of the period will stay at AAA rating only at the end of the period. Whereas there is an 8.33% chance that it will fall to AA rating, 0.68% chance that it will fall to A rating, and finally 0.01% chance that it will default. Now this is what we are calling as a transition matrix. We are talking about all the possible credit ratings. These are the from states, all the possible credit ratings. These are the to states. So from this to this, what are the probabilities? So these are empirical. Means historically we have observed, let's say 1,000 AAA companies over a period, and what we have observed is out of these 1,000 companies, let's say around 908 of them, they were in AAA only at the end of the period. So 90.8 of them are in the AAA rating itself, whereas approximately 83 of them have fallen in the credit rating to AA, and approximately zero point 0.6. So you can very well do this kind of calculation. So based on that numbers, how many of them have fell down to A rating, how many of them have gone to triple B. So that is what over a period has given this kind of a matrix. Now based on this matrix, I want to find out what should be the credit spread that needs to be charged for each of the ratings. Obviously the D, from a default, D is actually a default state, it's an absorbing state. You will not, a company which has already defaulted, it cannot come back to anyone. So there is a 100% chance that it will lie in the default itself. So this kind of a matrix is typically called as a transition matrix. First of all, it should be in a matrix form. If I look at the class of this, it is actually a data frame. I have to convert it into matrix, and if I have to do that, matrix will contain only numericals. So that's the reason I want to take out this first column. So first step I would like to do is ratings, where I am taking the subset of ratings without, so I'll take all the rows, but I'll not take the first column. So which is now giving me, if I'm looking at the ratings, so this is how my data is coming, right? But the class is still a data frame. So I have to convert it into a matrix. So what I'll do, ratings, I'll say as dot matrix, I'm converting it into a matrix, ratings. So now let's see if something has changed. If I'm quickly typing in ratings, okay, so these are remaining as headings, and these are the row headings, these are the column headings. Both I would prefer, even the row headings also, to be the same ratings itself, right? So let's say call names of ratings. So these are the column names. Whereas row names, if I am typing, if I am trying to find out the row names of ratings, right now they are null. So that's where I'll try to assign the row names same as the column name. Call names of rating. Now let's see ratings. If I am typing in, yes, I got yeah. So this is what is actually a transformation matrix. So we'll have to see. I mean, if it is a proper credit migration matrix or not. We have a few tests to ensure that. But at least it should be in the form of a matrix. So let's first look at the class of this. It should be a matrix now. It's no more a data frame, which is what it is. Now let's understand how we compute the credit spread, and once we have done with that, we'll use the corresponding package and the function. So credit spread, as I have already talked about, it's the risk premium that is demanded by the market, because there is some chance that a security which is having a AAA rating today, there is a 0.01 percentage chance that it will default. Similarly, a AA rated firm, there is a 0.01% chance that it will default. Whereas a triple C rated firm, there is a 19.79% chance that it will default within the next 1 year. So there is some risk associated with lending to these kind of firms. Now this is where I am talking about. If I am supposed to lend to these firms, I need to charge a premium. I cannot lend them at the risk-free rate of return. I should charge them a premium. So this is where, if I am going ahead with when I'm using the model out here, I am taking this empirical migration matrix as an input. Now we have seen, which is telling me for each of the credit ratings, what is the probability of default, and the last row is having default. So this is what is the typical input I should give. But normally, if we look at, if I want to find out the value of a particular security, right? Now the simple way is, I'll find the future value and I'll discount it by e to the power of rt. Right? At time t, whatever is the value of the security, I'll discount it by e to the power of rt, where r is the risk-free rate of return. This is in case of riskless kind of a security. But if I'm talking the same about a risky security, I have to take it whatever is the value of this particular security. I'll take it as e to the power of r plus credit spread times t. Now, in case of a riskless security, this Vt is already a known amount. It's a fixed amount. Whereas, in case of risky securities, this Vt is not fixed. Now, this Vt, again, different values of Vt are possible based on whether it is defaulting or not defaulting. Now, this is where I cannot, if I have to find out Vt, I can only find the expected value of Vt. So when I am talking about an expected value of Vt, here in case of credit, I am talking about two things. Because it's a risky security, there is a possibility that a default can occur, and there is a possibility that there is no default. Now, if there is a default, now there is some probability that a default occurs. That is what I am calling as probability of default, and there is a remaining chance that it will not default. Now, when a default is occurred, generally it's not that the company will lose everything. So there is only some portion of the loss, and that is what we are calling as loss given default. So instead of getting the whole, see, when there is no default, the value is still Vt. But when there is a default, the loss will be to the extent of LGD, which is the loss given default. So the value is simply Vt into 1 minus LGD. So whatever is the loss, post the loss, I can recover. So there is a kind of a recovery rate. 1 minus LGD is nothing but the recovery rate. So what we typically say is, there is a probability of default chance, whatever is the probability, that my value will be Vt into 1 minus LGD, whatever the LGD I am specifying, and there is a 1 minus PD chance that my value is Vt. So based on this, I can easily find out what is my expected value of Vt. So expected value of Vt is coming out to be this much, which is nothing but Vt into 1 minus PD plus Vt into 1 minus LGD into PD, probability of default. So this is what is my expected value. So basically here I should substitute that number. So I can very well say now my V naught, which is the current value, is for a risky security, V naught is nothing but Vt, expected value of the Vt, which comes out as, so here my V naught comes out as expected value of Vt, which is nothing but Vt into 1 minus probability of default plus Vt into 1 minus LGD into probability of default. That's the total expected value divided by e to the power of r plus CST. That's the present value. This is for a non-risky, this is for a risky security. But for a non-risky security, the same thing is coming out to Vt by e to the power of RT. And what I am saying is, because both of them are V naught, both of them should be equal. Based on that, I can very well compute my CST. So let's try solving it. Vt by e to the power of RT is equal to, let me expand it. Vt, if I take out the Vt altogether, it becomes 1 minus Pd plus 1 minus LGD into Pd, which is Pd minus Pd times LGD. This is the numerator. And the denominator is becoming e power RT times e power CS credit spread into T. So I am subtracting, I am cutting this out, I am cutting this out. So now I am getting e power credit spread into T is equal to 1 minus PD into LGD. From here I can find credit spread multiplied by T is equal to log 1 minus PD into LGD. And based on that I can find my credit spread is working out to trade spread is working out to 1 by T times log 1 minus PD times LGD. So that's how we are computing the credit spread. Right, you can very well find out this stuff, which can help you in doing the computation quite comfortably. So it's 1 by T times log 1 minus probability of default into the loss given default. Now probability of default is coming from my transition matrix. Right, we have seen that for each of the levels, what is the probability that this particular thing is going to default. The LGD I have to specify what is the loss given a default. So once I am specifying this, I can get my transition. I can get what is the credit spread that is associated with each of the rating levels. So for that I can use the package credit metrics package. So let me try to install that package, credit metrics. Let me install this particular package. Okay, the package is installed, so let's load that package as well. Now, okay. So let me load that package. The package is loaded. So once the package is loaded, I would be using this function called cm.cs. So let's see what it contains. cm.cs. So cm.cs is actually doing the computation of credit spread for us. It computes the credit spread for each rating of an empirical migration matrix. So we have already got the migration matrix. First of all, we did not check whether it's a migration matrix or not. So let me come back to this. For testing the migration matrix, we have something called cm.matrix. Let me use that function first. First, I want to test whether it's a migration matrix or not. So if I look at cm.matrix, so it's a testing for migration matrix. Tests if a given matrix M is a migration matrix or not. So the dimensions, what is the migration matrix here? Dimensions of the migration matrix should be at least 2 by 2. Row and column dimensions must be equal. Yes, it has met. We have 8 rows and 8 columns. So that rule is met. The values in the migration matrix should be between 0 and 1. Oh, that is not the case. They are all much higher because they are in terms of percentage. So basically it's better that I divide it by 100, right? So the value should be between 0 and 1 and the sum of each row should be 1. If I sum up, I think it will come out to 100 instead of 1. But anyhow, let's check out if this is working for us. cm.matrix, right? Let's quickly check this out. cm.matrix of ratings. Now it is saying error. Probability is larger than 1 in the input data, which means it's not a migration matrix because the numbers should be in between 0 and 1, not something like this. So better let me do one more thing. Ratings, I'll divide each of these numbers by 100. So that now if I want to test the CM matrix, so there is nothing, no error coming out. If no error is coming out, it means it's a migration matrix. So I am able to check whether there is a migration matrix or not. So this is what I have documented here, the dimensions of the migration matrix. So this is what was explained out there. So if it is a migration matrix, obviously I will not get any error and just I will get the command prompt, nothing else. But if there is an error, I will get a message like this. So now we have got it as a migration matrix. Now we will go ahead and see the cm.cs. It computes the credit spread for each rating given a migration matrix. The failure limit is the quantile of the failure probability. So all I need to give is cm.cs. M and LGD is also something that I have to give. The loss given default. So we can assume some kind of a loss, let's say the 50% loss and 50% could be recovered. So we will set that. So if I say cm.cs, wherein I am giving my matrix ratings and I am also giving LGD is equal to 0.5. So 50% would be recovered. So based on that, I am getting an information that for a AAA for 1 year, so if it is a AAA related security, for a AAA rated security, the credit spread that I am applying is 5 into 10 to the power of minus 5. So it's like 0.00005 or it is like 0.005% is the extra that I am charging. And the same goes with AA also, right? For 1 year, I don't see that these two are having any kind of a big difference. So the credit spread is more or less similar 0.005% for AAA and AA. But when I'm going with A, it is saying 3 into 10 to the power of minus 4, 0.0003, which is like 0.03% is the credit spread that is getting charged for a A-rated security. And for triple B, because the risk is much higher, it is coming out to 9 into 10 to the power of minus 4, which is working out to 0.0009 or 0.09% is the kind of. Same way, if I look at triple C rated, we see that it is 1 into 10 to the power of minus 1, which is 0.104, which is like 10.4% is the premium that is being charged for a triple C rated kind of a security. So you could see, depending on the credit rating, how the credit spreads are typically varying. There is a wide variation in the credit spread between a AAA rated security versus a triple C rated security. So that's one thing. But the same thing, if you see that if the LGD is going lesser, so let's say if I am saying 70% is not recovered, the loss given default is 70%, then suddenly you could see that for though the numbers are much lesser for AAA and AA, but for A you could see the numbers have gone up. Triple B also they have gone up. So for each of the levels we see that the spread that has been set aside is going up quite heavy, has gone up quite heavy. So that's what is based on the LGD. Now, instead of 1 year, if I want the same exercise, let's say for 2 years, 3 years, etc., then it's better that I find out the 2 year transition matrix. Right now I have a 1 year migration matrix. Now how do I get a 2 year migration matrix? Let me take it as ratings 2, where I'll do a matrix multiplication. So matrix multiplication is done by percentage star percentage. So I'll simply say ratings percentage star percentage ratings. So now if I look at ratings 2, this is for a 2 year period. So if I want to see here a AAA rated security at the end of 2 years becoming default, the chances are 0.0002. Whereas for a AA rated security after 2 years, the default, the chances of default are 0.0003. So these are the numbers. Now based on them, let's say for the end of, so if the same securities are going for a 2 year kind of loan with let's say the same LGD of 50, then I can very well look at how much spread. So in this case, it comes out that for a 2 year stuff, it's better to have for a AAA rated security, let the spread be 0.01%. For a AA also it is again 0.01%. For A it is 0.07%. For triple B it's 0.3%. For double B it's 1.3%. For B it is 5.34%, and for triple C it is 18.17%. Now the same thing if I am looking at for a 3 year period, so I can create ratings 3, wherein I'll take the ratings 2 multiplied by ratings. Now based on that I can get ratings 3 again with different probabilities. AAA going into default, this is the probability. AA going into default, this is the probability. A going to default, this is the probability. Triple C going to default, this is the probability, and so on. Based on that, if I am looking at the spread for a 3 year period, if I am looking at the spread with the same loss given default and the recovery rate, I see that I should charge 0.02% extra for a AAA rated security, 0.04% extra for a AA, 0.14 for A, 0.7 for B, 2.24 for double B, and 8.02 for B, and 23.94% for C. So that's how you could see by evaluating the rating, how the probabilities of default are coming up year over year. We can get into the process of computing what should be the spread that should be levied for securities of each of the layers. So that is how we can compute the credit spreads. Once you have a rating transition matrix, as we have seen the formula, it will take the probability of default as well as the loss given default. Now, if possible, we could also give the loss given defaults as a kind of for each one. Let's say for AAA, the loss given default is 0.9. For AA, it is 0.8. Then for A, it's 0.7. For the triple B, let's say, is 0.6. For double B is 0.5. For B is 0.4. And for triple C is 0.3. And for default is 0. Now, based on that, right now you could see the requirements have changed a little bit. Oh, these are not recoveries, sorry. These are loss given defaults. So I'll do it the other way. So the loss given default is 0.1 here for AAA, 0.2 for triple B, 0.3 for AA and A. Triple B is having 0.4, B is having 0.5, double B is having 0.5, B is having 0.6, triple C is having 0.7, and let's say D is having 1. Even if I don't consider D, that's okay. Now you could see if the loss given default, so I can give different loss given defaults for each of the credit ratings also. So I could see that only this much is required. 0.004% is the credit spread in case of triple A. 0.016% is in case of AA rated. Then similarly we have 0.0848 for a case of A, and so on. Now this second can give me some other insight. If the loss given defaults for each of the types are different, I can take that also as an input to finally compute the credit spread in the case of each of them. So the major input is the rating migration matrix and the loss given default. So we have different ways of computing the same. Once I have that information, I can very well input the same to compute my credit spread associated with each of the rating levels. I hope you got a good amount of understanding on how do we compute the credit spread based on the credit ratings. If you have any further queries, you can very well get in touch with me by giving me a call on the number that I have given below, or you can send in an email at the email address provided below. Thanks a lot for listening to this session. Thank you very much.